All right, the recording has started. So the first type of question is going to be tasking you like qualities of numbers. So I'll start with like a whole number, and then we'll get a little bit more complicated. So for this one, it'll look like exactly like this, and I'm just going to ask you to circle everything that applies to this number. So let's start with 3 first. 3, the only things that can multiply to 3 is 3 and 1, so it's considered a prime number. 3 is an odd number, not an even number. 3 is an integer. An integer, by the way, is a whole number. Whether positive or negative, it's a whole number. So no decimal, no fraction. It is rational. Rational is that I could write it as a fraction. And it is a real number. Okay. So if 3 was on the test, this is what you would have to circle, okay?
Can you define a real number again?
So if imaginary numbers are square roots of negative numbers, then real numbers are not that.
Okay.
That'd be probably easier than explaining what real numbers are. Okay. All right, I'm going to clear it for me. Any questions on that one?
Can I write that down?
Yeah. So write down the words, I guess. So
What's composite?
composite means two things multiply. So like 6, not only 1 and 6 multiplies to it, but 2 and 3 also multiplies to it.
So like,
Again, prime and composite numbers can only be whole numbers though, okay? So if I have decimals like 2.5, it's neither prime nor composite. It doesn't fit for that set. Nor it's neither even or odd, okay?
okay. I need to write down 3 more.
I know, I put a lot of words there. I should have waited.
Well, I know it's
You gotta
not E.
try to reuse the words for these, okay?
What are happy primes?
Happy prime? I'm not gonna ask that, but those
No, but I want to learn about it. They talked about it in Doctor Who.
I'll check it in a
You
second.
know
And
the Doctor Who episode came out on my birthday? I've already watched it 3 times, and it's literally the best thing I've ever seen.
is it a new season or just a new
It's a
episode?
new season.
Ah, okay.
I mean, it's.
Is it a new doctor now?
Yeah.
Okay.
Well,
Is there a girl then?
Yes, and also no.
What do you mean?
It's okay. Basically, the 10th Doctor was played by David Tennant. This is the 14th Doctor. It's a different person, but it's the same face.
Oh, okay.
Like it's not 10 again. It's 14, but 14 and 10 look the same and have the same like characteristics.
Same actor, but
Yeah.
different characters. I got you.
Yeah, but it's like that's a thing. It's like, oh, why did this face come?
Yeah,
out?
yeah,
It's
yeah.
like a whole mystery. But it's not like a new season because there are 3 specials. There's this one. The next one is Wildly Under that's coming out in December.
No.
And then the last one is The Giggle, and then the new season will start. And the new season is going to be a different actor than David Tennant, whose name I cannot pronounce.
That is a lot. Hopefully, yeah, whoever watches this video will get that. All right, square root of 4. What is the square root of 4?
2.
So we have to think of it as 2, not the square root of 4.
We have a gift for you so you don't mark us late.
Are
Kinda
you
like
bribing
blackmail.
him?
So,
Well, do you think
non-recordings. Now, that being said,
what is it?
it's 2. This is a video review. I'm recording. Alex, I'm recording, okay? So, since it's 2, we got to consider it 2. 2 is the only even prime number. So it's a prime number because it's only 2 times 1. It is even. It is an integer. It is rational, and it is real.
What's an integer?
An integer is a whole number of some sort. So like 5, -6, something like that is an integer. It's a whole number. So like,
A number, basically.
yeah, any whole number. So like -120, that's positive or negative. So -123, integer.
So basically any number.
No, because a decimal would not be an integer.
Oh, anything except decimal.
Yeah, like 2.5 would not be a decimal integer. Yep. All right. Let's say square root of 5 though. The square root of 5, that is some crazy random decimal like 2.4, blah, 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 something like that. So this is neither prime nor composite. It's not a whole number. It has to be a whole number to be prime or composite. It is neither even or odd. It has to be a whole number to be even or odd. So as soon as you know it's not a whole number, the first 4 is already blank. Oh, the first 5 is already blank because integer, by definition, is like a whole number, positive or negative. This case, when you write this, it's a decimal that never repeats nor has a pattern, and it never ends. So because of that, it is irrational. Even though it is irrational, it is still a real number.
So anything is a real number.
There's only except imaginary numbers. I'll talk about that in a second.
10,
Oh, the I.
decimals that go on forever cannot be written as fractions.
Technically, it can because like 3.3 repeating.
Wait, so how do I?
Like if there's no repeat, there's no pattern, so no repeating. So 0.3 is 1/3. That could be written as a fraction. Next one. Let's say, I'll just do an imaginary right now. Square root of -4. The square root of -4, which you kind of think, oh, it must be, It is imaginary. It is not 2i. So it's not prime, it's not composite, it's not even, it's not odd, it's not integer, it's not rational, it's not irrational, it's not real. The only thing it is imaginary.
Is it because it's like plus minus 2?
No, square root of 4 is technically plus or minus 2. But the square root of negative 4 is imaginary.
I always write it like I. Isn't it like the square root of negative 1i?
It would be 2i if you would rewrite this. Because you would do the square root of the actual number, 2, and you put the I to represent it was a negative square root. Again, but I'm not asking you to translate that, so you don't have to worry about that. All right. Another one. Say 3/5. Okay. Again, if it's not a whole number, the first 5 is going to stay uncircled. Okay. But it is written as a fraction. Because it's written as a fraction, it counts as rational. Since it's rational or irrational, it is technically real also. It is not imaginary, so it's real. At minimum, one of these two will be circled. Okay? At minimum, one of these two will be circled. So this one, the only one that fits is rational and real. Integer is a whole number. Even odds only describe whole numbers. Prime and composite only describe whole numbers.
What's composite?
So like a number that has multiple things that multiply to it. So like 6 is 1 and 6, and 2 and 3. 2 times 3 gives you 6.
So it would be an example of a non-composite.
So a prime number would be 5 because it's only 1 and 5.
Oh, so only one and another number.
Yeah, and itself, I should say. Now, here's an interesting thing. The number 1. The number 1 is neither prime or composite, so you got to leave those blank, okay? It is odd. It is an integer. It is rational. It is real. But it's not prime or composite. Don't forget that, okay? I think 0 technically falls under a composite, but I could see if it's undefined also as neither.
Will you give up 0?
Probably not, because I'm not sure myself. I'll have to look that up. So, but I would define it as a composite because it has more than one factor. So, but that's a separate question, I guess. So that's like your first section of your test. It's just straight up like primes and stuff. All right. Second part is finding the least common factor and the greatest common multiple. Wait. I'm sorry. Greatest common multiple and least common.
Does it make a difference?
Yes, it does. Greatest common factor and the least common multiple. It does make a difference because if I say greatest common multiple, which is like what do they multiply to the biggest number, that's affinity because you can just keep going and going. And then vice versa. If I say the greatest common factor or the least common factor, it's always 1 because everything's multiplied by 1. So the other way, otherwise it's trivial. Let's say. Yeah, exactly. So let's give you.
Except that everyone will think you made the other thing.
No, that's just cruel. So let's say 6 and 8. I'm going to use 6 and 8 for both of them, okay? Now, 6 and 8, we could kind of think of our head. What things both multiply to 6 and 8? Well, I could always break it down to 2 and 3. I could break this down to 2 times 2 times 2. Hey, there's a 2 in common, so the answers go to be 2. All right? So that's the hand way. Let me show you how to do it with a calculator to make your life easier. So if you open up your calculators, and if you go to y equals, okay? Y equals. Since we're looking for factors, we're looking for things that divide into 6 and 8, okay? So if I do 6 divided by x, and let me do on the second line, 8 divided by x. We're going to click y equals, top left. Top left. Then you're going to do 6 divided by x and 8 divided by x, okay? Now I could graph that. This is going to give me 2 lines, but that doesn't really help me. So I'm going to go look at table. So I'm going to click second and the graph button, which is table. Now I'll scroll down starting at 1. So at 1, it lists all the factors. For example, 1 times 6 gives you 6, and 1 times 8 gives you 8. Duh. If I scroll down, here's a 3, here's a 4. Here's a 2. That's a decimal. I don't care about the decimal ones. Okay. So y1 was the first one I put in, which is 6 divided by 8. And y2 is the second one I put in, which is x divided by 8. They even color coded. This calculator color codes it, but yours could usually be black and white. So you should go up to the number that you need to check, which is 8. It might not fit in one screen. This one happens it does. So what you do is you look at your tables and see what is the biggest number they have in common. And the biggest number they have in common is 2. 2 is the biggest number they have in common. Which means, I don't know. I don't know how the search function works like in that sense. So in that case, the answer is 2. That's the greatest common factor. That's one way to do it. With a small set of numbers, it was kind of easy to do by hand. The least common multiple. Again, I can break it down to the prime factors. So 6 is 2 and 3, and 8 is 2 times 2 times 2. So the least common multiple is kind of the reverse. In this case, I cared what they were the same and marked that. In this case, I care what's different. So in this case, 2 and 2 are the same, so I'm not looking at that. So what I'm looking at is the things that are different. 3 times 2 times 2. Okay? 3 times 2 times 2 is, and I needed one that was in common. So the one in common, like, you don't have to double count it. So you'd only put it once. So it's going to be 2 times 3 times 2 times 2. I apologize for that. So that's going to be 24. And 6 and 8 both multiply to 24. Okay? So you can take the primes. Any matching, you only count once. Okay? Only matching, you only count once. So this was the matching one. And then these are all the unique ones. And then multiplies to 24. That's the easy way to do it. You could actually just multiply by paper, by hand, or you could also use the calculator for your fact. You could always just do 1 times 6, 2 times 6, 3 times 6, and just work up that way. Or for this one, you could just do, since we're multiplying, we're finding what multiplies to it, the multiple, we're going to do 6 times x. And we're going to do 8 times x, okay? Then we look at the table. Again, you're looking at the answers only. I don't really care about this. I'm just looking at the answers. I'm looking for the first time they match. And if I look, 24, they'll never match on the same line, by the way. But they match here. 24 is on the red one at 3 and on the blue one at 4. Since they're both at 24, or they both have 24, I know that is the first time they are matching. So that means it is 24. So you can do it by calculator or you can do it by hand. Small.
But where always be a point that they have? Like, what if they never match?
So the highest maximum point could always be just the multiple of them, 6 times 8. So you know that's your upper limit. Sometimes it could be, so you got to think of it, there's an upper limit, you could do it faster, okay? Because the upper limit here would be 48, right? But 24 beats it to the punch. Okay? Same thing here. Is there something that won't match? If nothing matches, they always match with 1. So technically it could be 1. If they're relatively prime, we call that, okay? All right, so that's the identification stuff. Here's the math stuff. You're going to add fractions. 2 plus 3, or 2 over 3, plus, let's say, 4 over 5. In order to add this, though, we need a common what? Denominator, which uses the skills from the other part. I need what they multiply to. Or, if you just feel lazy, you could just always just multiply it by the opposite number. So I'm going to do 5 over 5. And this one I'm going to do 3 over 3.
Isn't that just 1 though?
Not necessarily. Because there's a plus sign in between. If it was equal sign, you would do plus 1.
Did you say,
You are multiplying by 1 because you don't want to actually change the number. You don't want to change the value. Otherwise, I'm rewriting the question.
You said we're adding 5 over 5 and 3 over 3. I'm like, wait, what?
No, I'm multiplying by 1. So, this is going to be 10 over 15 plus 12 over 15. Once again, if you ever worried about what's the common one, just like we said before, you could just multiply it with each other. That will guarantee be matching. So I get 22 over 15. I have to check if anything's divisible, but in this case, no, it cannot be simplified. So 22 over 15 is it. You could, but I'm not asking you to do that. But you could do 1 over 715. That's the same thing. You could turn it to decimal if you really... No, don't turn it to decimal, actually. That's just annoying for me. Okay, next one. Let's do 3 over 7 minus 2 over 21. So in this case, we need a common denominator. Again, equal and multiplication, addition and subtraction. And before? If possible, no. She just asked if this is the same, but you don't need to do that. That is the same, but you don't need to do that. So this one I want matching. 7 goes into 21. So this one I'm just going to multiply it by 3 and 3 and 1 by 1. I'm not really changing this one. Just to represent I am multiplying by something, but not really anything changing. Because 21 times 1 gives you 21. 3 times 7 gives you 20. Exactly. I could have also done 7 on this side and 21 on this side. Usually you get bigger numbers than that, though. That's fine. But this one I saw, so let me do it. So 9 over 21 minus 2 over 21 equals 7 over 21. No need to change it to a decimal or anything. That you actually have to simplify. You're correct, which is 1 over 3. My fault. Just a note, if you did do like the thing where you multiply this side by 21 over 21 and this side by like 7 over 7, there's almost a guarantee you're going to simplify at the end, okay? Not necessarily, but there's a guarantee you're going to simplify at the end because you could have simplified earlier. So you pay it forward or pay it at the end, it doesn't matter. Okay? Next one's multiply. So 3 over 7 times 4 over 5. Multiply is super easy. Don't have to set up anything. You just straight up multiply straight through. No cross, straight through, okay? So this is going to be 12 over 35. Proportions we did in the last test or a test before. Did we do anything with proportions? Okay, never mind. Proportions is where you cross multiply, but we're not doing proportions in this test. Okay. Division. 3 over 7 divided by 4/5. In order to write this better, this is divided by 4/5. So what I'm going to do is use keep, change, flip. So 3 over 7 stays exactly the same. I'm changing the division to a multiplication, and I'm reciprocating, or flipping, the fraction. So 5 over 4. That's going to be 15 over 21. Yeah. So next one, you must be wanting oil then. So next one, 1 plus a half divided by 2 minus 2/3. So this is a fraction in a fraction. So the best way to deal with this is we deal with it one at a time, okay? So I'm going to rewrite the whole numbers as fractions. 1 over 1 plus 1 over 2 over 2 over 1 minus 2 over 3. From there, I need the fractions to match on the top and the fractions to match on the bottom. So in the top fractions, this needs a 2 over 2. This needs a 1 over 1. This needs a 3, so 3 over 3. This needs a 1 over 1. Do you have to write 1 over 1? Not really. So 2 over 2 plus 1 over 2 all over 6 over 3 minus 2 over 3. Add the tops of the fractions. So 3 over 2 over 6 minus 2 is 4 over 3. It's basically a combo of all the fraction things in one question.
Wait, how do you get 7 times 4?
What the? In the previous one? 7 times 3 is 21.
Then how can you do 7 times 4 is 21?
Where am I talking about?
No, I was just confused.
Oh, this should be 28. You're right.
Oh, okay, I was so confused. I was like, wait, did I not know that?
No, I'm wrong. Thank you for catching that. Someone who's watching the video would be like, oh my god, I'm messing up.
For the second step where you put the orange
Mm-hmm.
on the bottom, why should you feel like 3 times 2 over 1 instead of 2 over 3?
It has to be the same on top and bottom. Otherwise, if I change the top and bottom, that means I change the number overall. Because 3 over 3 is equal to 1. So it's not changing the actual value of it. It has to be the same on top and bottom. You have to be consistent in that case. All right. This is 3 halves divided by 4/3. That looks horrible that way. So let me rewrite it like this. 3/2 divided by 4/3. Wait a second. When it looks like that, what can I do? Keep change flip. So what it turns into is I can rewrite this as 3/2 times 3/4. I flipped this fraction. Which means it's going to be 9/8. Well, yeah, I'll leave it here.
And not either of those has to be
I'm going to have like 2 order operation questions because that was technically in the book. I don't want to crush it, then like I'll just hold on to it. Any question on that while we're here?
Just don't change it. I don't have a question.
Yeah, I got you.
Maybe not have to just be
No, it is Wednesday though. Just as a reminder. What do you say? Happy primes? What do you?
yeah, happy fun.
Happy prime?
Maybe off the card.
Good. Get it?
I still need that.
I'll leave it on the board for you. I'm just gonna. Next thing is just order operations.
What's the date?
3 times 2 plus 29. 7 minus 10 divided by 5. Wednesday. So remember PEMDAS? All right. So first off, we do any parentheses, no parentheses. Now we do any exponents, there's no exponents. Now we do multiplication and division from left to right. So this one is going to happen first. 6 plus 7 minus 10 divided by 5. Now multiplication and division. There's no more multiplication, but there is a division over here. So negative 10 divided by 5 is 2. So 6 plus 7 minus 2. Then we do addition and subtraction in order. So left and right. 6 plus 7 goes first. So 6 plus 7 is 13. No. Yeah, 13. And then 13 minus 2 is 11. I'm not going to go too crazy about order operations, but there's 2 questions on it. Okay? That's your whole test. Feel prepared?
I thought there was like so much more further stuff.
I gave you more like different type of numbers, like pyramid numbers, but that's not necessarily tested. It did.